For more than 4,600 years, the pyramids, especially the Great Pyramid of Giza, have remained the most studied yet least understood megastructures on Earth. Despite advances in archaeology, structural engineering, and high-precision measurement technologies, many aspects of their construction and purpose challenge our current models of ancient human capability. When surveyed with modern satellite-based instruments, the Great Pyramid demonstrates an astonishing level of precision. Its four sides differ in length by less than 5 centimeters. The base is oriented almost perfectly along the cardinal directions, with a deviation so small, 0.05 degrees, that even today's surveying standards would classify it as exceptional accuracy. In 2013, a team from the University of Leeds used 3D scanning to confirm that the pyramid's original casing stones were polished to such precision that the joints between them averaged 0.5 millimeters, a tolerance comparable to modern machine manufacturing. Such findings raise a profound scientific question. How did a civilization without steel tools, laser leveling devices, or advanced mathematics achieve results that rival or surpass modern engineering norms? Architectural features. The pyramid's geometry appears simple, a square base rising to a single apex. But its mathematical properties reveal a deeper level of sophistication. 1. Mathematical ratios embedded in the structure. Studies by architectural mathematicians show that the ratio of the pyramid's perimeter to its height equals 2 pi within 0.05% accuracy. The relationship between the slope angle, 51.84 degrees, and half the base encodes the golden ratio, 1.618. Whether intentional or coincidental, this suggests the builders possessed an intuitive or formal understanding of geometric harmony. 2. Geological knowledge. The pyramid sits on a prepared limestone plateau. Geologists from the Egyptian Geological Society discovered that the bedrock beneath the center was carved into a natural limestone basin, reducing the mass of stone needed by nearly 20% and increasing structural stability. This demonstrates advanced planning and knowledge of natural terrain characteristics. 3. Structural engineering. Modern engineers note that the pyramid's weight is distributed through step-like internal layers, preventing collapse. The king's chamber uses granite beams up to 70 tons, stacked in multi-layered, relieving chambers, to distribute stress, a technique comparable to modern load-bearing principles. These engineering decisions reveal a sophisticated understanding of forces and pressure, centuries before formal engineering science existed. Internal structure. Beyond the grand gallery and the known chambers, the internal layout suggests intentional symbolic or functional design. 1. Resonance characteristics. Acoustic engineers studying the king's chamber discovered that its dimensions create harmonic resonances at specific frequencies. This chamber acts like an acoustic cavity, amplifying tones around 440 Hz and 520 Hz. Some researchers propose that this design was intended for ceremonial chanting or ritual resonance. 2. Thermal anomalies. In 2016, a thermal scan by the Egyptian Ministry of Antiquities detected heat anomalies at the lower northern blocks, indicating hidden cavities, airflows, or structural features beneath the casing stones. These anomalies support theories involving concealed entryways, additional chambers, or differential stone densities. 3. The Big Void muon tomography has revealed a void with a volume exceeding 100 cubic meters, comparable to a small aircraft fuselage. Scientists cannot yet determine its purpose, but theories include a structural relieving space, a hidden gallery, or part of an internal transportation system used during construction. This discovery alone could sustain decades of research. History and possible construction methods. 1. Labor organization and logistics. The idea that 20,000 to 30,000 workers constructed the pyramid is supported by evidence from workers' villages discovered at Height El Gurub, bakery and brewery remains, and skeletal injuries consistent with heavy labor. Yet these findings do not fully explain the logistical mastery required to place a stone every 2 to 3 minutes, the rate needed to complete the structure within 27 years. 2. Water-lubricated transport. Recent experiments by physicists at the University of Amsterdam show that adding water to sand reduces friction by up to 50%, making it easier to drag sledges. Ancient tomb paintings depict workers pouring water in front of sledges, suggesting Egyptians understood this principle centuries before fluid dynamics was formalized. 3. Internal ramp theory. More evidence. Infrared scans found helicoidal temperature patterns consistent with spiraling cavities. 3D simulations show that a ramp winding inside the pyramid would reduce required force by 70%, making it a feasible construction method. 4. Geopolymer theory. Continued debate. SEM microscopy reveals microbubbles and amorphous bonding in some limestone blocks, characteristic of karst materials. However, many geologists argue these features may be natural diagenesis. The debate remains active in scientific circles. The true purpose of the pyramids. 1. Not just tombs, the lack of inscriptions, the empty sarcophagus, and the absence of funerary goods strongly imply alternative functions. Egyptologists note that all proven royal tombs from later periods contain extensive funerary texts, yet the Great Pyramid contains none. This suggests the pyramid may have served as a symbolic resurrection monument, a cosmic alignment device, or a ceremonial structure rather than a burial tomb. 2. Astronomical symbolism. The descending passage aligns precisely with the star Alpha Draconis in 2500 BCE, the North Star of that era. The ascending passage correlates with Zeta Orionis, Alnitak, reinforcing the belief that the pyramid served as a stellar map of the Egyptian cosmology. Unsolved mysteries. 1. Electromagnetic phenomena. The 2018 ITMO study reveals that under certain conditions, the pyramid acts as a resonant cavity for electromagnetic waves in the UHF range, 200 to 300 meters. This is not evidence of ancient energy devices, but it does raise the question, did the builders intentionally design these properties, or are they coincidental? 2. Precision beyond practical need. Why would a tomb require mathematical constants, stellar alignments, and extreme precision? This question remains unanswered and fuels ongoing speculation. 3. The age controversy. Geological evidence of rain erosion suggests the structures may be older than expected, potentially dating back to a wetter climate phase. Although heavily disputed, it challenges the linear timeline of human technological progression. The pyramids remain one of humanity's greatest scientific puzzles. Their architectural perfection, intricate internal structures, unexplained voids, astronomical alignments, and anomalous physical properties indicate knowledge that may have exceeded what is typically attributed to Bronze Age civilizations. As modern technologies, like muon tomography, high-resolution 3D modeling, and advanced geochemical analysis, continue to evolve, we may inch closer to understanding the true nature of these structures. Yet, each discovery also unveils deeper questions, reminding us that the pyramids are not just relics of history but active frontiers of scientific exploration.